I realized after recording the first video, I didn't talk about creating a material for the landscape. So let's do that real quick. I'm going to right click on the content browser, select material. I'm going to name it M Landscape Demo. And we're going to keep it real simple. We'll set the color to black, the specular value to 0.2, and the roughness value to 0.9. Go ahead and create a material instance. I don't really need this to be an instance. We're probably not going to be playing with any of the parameters, as there aren't any, but it's a good habit to get into. Select the landscape, make sure you're in selection mode. Scroll down in the details panel a bit, you'll see a slot for landscape material, and we can just drag and drop. Okay, so now we've got a nice basic material that'll help highlight the work we're doing with our PCG graph. I have a more in-depth landscape tutorial that you can check out. I'll link to it up here. All right, so what we're gonna do now is filter out the points that are up here on the mountains. And the first filter that we'll add will be looking at the height of each point. So we'll type in the word attribute. I'm going to hit A here. And then I need to select input in as opposed to the outputs. You can see there's two outputs and one input. And this will be the data coming into our filter node. You can see we've got position X, position Y, and position Z, and Z is the one that we're going to be filtering for. So for our target attribute, we'll go to point, and then position, and then we can just add .Z. So this is going to be a constant value. We could use an attribute if we wanted to evaluate this filter based on some attribute data per point, but we're just going to be sort of chopping everything off beyond a certain height, so we can keep this pretty simple. So I need to add a debug, because one of the peculiarities about working with the filter attribute elements node is if you try to debug it, you're just going to debug the points coming in. So we're not going to actually get any useful information there. I'm going to turn the debug off on our surface sampler, make this a little bit bigger. And you can see the points that are surviving our filter. Here are any points that are greater than 0 in their position Z. And we don't really want the ones that are greater than, we want the ones that are less than. So we can just select less than. And that's doing a pretty good job of getting rid of our mountain points, but there are still a few. So the next thing that we can do is we can filter out any points that are on the hillsides. So we can apply a value to the density that is derived from the point normal. The normal is basically, it's a z vector. So if the z vector is pointing up, our density is going to be closer to 1, and if it's pointing to the side, it's going to be below 1. So we just need to type in normal to density. And if I debug this, it's not super easy to tell, but there is a slight difference, a very slight difference, between the points that are pointing up and the points that have a little bit of an angle to them. So this data is baking this value onto the density. So if I wanted to see what that looked like, I could turn on my attribute data here and scroll over to density. You can see some of these points are significantly below 1, and most of them are going to be pretty close to 1. So now that we've got that, we can add another attribute filter. We'll set this to density. As the attribute that we're looking at, we're going to use constant threshold once again, and I'll set this to 0.9. And then we'll take this inside filter and plug it into our debug and turn it off over here. So if I increase this to 9.5, we should see a few more of those points start to fall off. If we go much higher than 9.5, we're going to start removing points from the flat area here, because there is some variation. Just because it's an actual height map, You can kind of see that bumpy stuff, right? So we don't want to go too high here, but that's fine. I'm actually okay with a few little points kind of breaking up that boundary. So that'll be an effective way to get our mountains out of the equation here. The next global operation we want to perform on our source points here is to zero out the rotations. I'm going to go ahead and hold the Alt key and click on that wire to disconnect the debug. We're going to do this with a transform points node. Tap the D key to enable debug on this, and all I've got to do here to zero out the rotation is to make sure my rotation min and max for X, Y, and Z are set to 0, which is the default, and then turn on absolute rotation. When I do this, keep an eye on these points over here, and you'll see their rotations are all zeroed out. So they are all oriented vertically in their Z axis now. Okay, at this point, I want to go ahead and import my road mask, which is just saved as a PNG. So we're going to create a get texture data node. We'll go ahead and drag our road mask in. And I'm going to turn off the debug on my transform points and turn it on for get texture data, and we'll just zoom up a little bit. So we're not going to see anything. We've got to do a couple of things. I'm going to turn on use absolute transform. The density source channel we want is going to be red. Red, green, and blue are all going to be the same because there's no color here. It's just black and white. And then we need to open up our transform. So if I set this to a larger number, let's say 1,000 by 1,000, you can see over here, we're starting to get some information rezzing in. But it's not really all that useful. So what we need to do is we need to set these two values so that they are big enough to fit our landscape. And if we look at landscape, it is 2017 by 2017. So here's what that means in terms of this texture data. This is 2017.00. That's how many units we're actually dealing with. And if I divide this by 2, we're going to get 100,850. So I set this to 100,850 for both X and Y. Now we can see that we are generating those points in a grid that is the same size as the landscape. It's pretty dense because of the size of our texels is fairly small. Setting this to 100 will make this a little bit more performant. Okay, so there we go. Now we've got to figure out how to get this data onto our cleaned up landscape sample points. So I'm going to pull off from the get texture data. Actually, let's pull off from transform points. And I'm going to use a sample texture node. And you can see here we've got an input for base texture. I'm going to turn off the debug on our get texture data. And then turn it on for sample texture. And you can see that information is now baked into the density of our source points on our landscape, like so. The number of points that we're generating here is probably a little bit below what we're ultimately going to need. Now that we've removed all these other points, we can probably increase our sample size a little bit. But before we do that, let's transfer this data out of the density attribute and into a new custom attribute. So we're going to use a copy attributes node. And I'm going to plug our input into both the target and the source. So the input source here, that's going to be density. And then we're going to create a new one, a new attribute here called roads. So if we inspect copy attributes now, what we will see is we have a new attribute here called roads. And then these values correspond to whatever the density was. So if we tap the D key, we'll be able to see this again. You can see the road value for this point is 0.958. And if we look at density, it's 0.958 and 0.086, 0.086, and so on and so forth, right? So this is sort of transactional attribute that we can capture data with a get texture data node, and then we can bake it off into custom attributes as we go, and then we can reuse our density channel to capture other data. And as it turns out, capturing more texture data is what we are going to be doing next, so stick around for that.